So for next properties, multiplying by Tn function, we can refer to the textbook page 136. So we will apply multiplying by Tn, whereby T of n is multiplied with any function of ft. So this is the formula for the multiplying by Tn. Laplace t the power of n multiply ft is equal to -1 to the power of n dn over dsn fs. So means that for this one, we have to apply the differentiation. So we can refer the formula in the table of the Laplace transform. Okay, so this is the formula for the multiplying by Tn, whereby we have t the power of n multiply with the ft. So this is the formula. So now let us try to solve this example. By using properties of the Laplace transform, find the Laplace transform for the following function. So as we can see here, you have t multiplied with the exponent -2t. For this question, we can solve by using two properties. Is either by using first shift or by using multiplying by Tn. Why we can solve this question by using two properties? Because we have t multiplied with the exponent. Okay, so if we consider as Tn multiplied with any other function, so this one we will apply the multiplying by Tn, which is Tn is t the power of 1, ft is the exponential term. But if we want to solve by using first shift, the properties for the first shift is we have exponent at multiplied with the ft. So we also have here exponent multiplied with the t. So means that for this question, we can solve by using two properties. It's either by using first shift or by using multiplying by Tn. So I will show you first solution by using first shift. We have t exponent -2t. So if we want to solve this function by using first shift property, we have to follow our step, which is the first step. We have to determine a, we have to determine our new ft. The second step, we have to find the fs. The third step, we have to shift fs minus a. Okay, so that is the step if we want to solve by using first shift. Okay, so first we have to determine our a. So from exponent -2t, our a is equal to -2, and our new ft is any other function except the exponential terms. So we close the exponential terms, our new ft is equal to t. So from our new ft here, we proceed for the second step. We want to find the Laplace transform for the new ft. We want to obtain the fs. So fs, solve the Laplace transform for the t. So refer to the table. T the power of n will become n factorial Sn plus 1. So from t the power of 1, our n is equal to 1. So therefore, Laplace of t will become n factorial, which is n is equal to 1. So we substitute n factorial become 1. 1 factorial over s n plus 1, which is 1 plus with 1. 1 plus with 1. So now we simplify 1 factorial over s the power of 2. So now proceed for the last step. Shift fs minus a. So we already declare our a is equal to -2. Therefore fs minus a, s minus -2 will become s plus 2. We will shift position of s to become s plus 2. So 1 over s plus 2 the power of 2. So this is the answer whereby we solve by using first shift. We have solved this question by using first shift properties. and we get the answer is 1 over s plus 2 the power of 2. So now let us try to solve the same question by using multiplying by Tn. So this is the step for the multiplying by Tn. So for first step, you have to determine the n and ft. The second step, we have to find the fs, which is the Laplace transform for the ft. The third step is we have to apply the formula. So what is the formula for the multiplying by Tn? You have to refer to the table of the Laplace transform. Negative 1 the power of n, dn over dsn. So in this bracket, you have to substitute your fs you obtain from step 2. Step number 1, determine n and your ft. So we have t exponent negative 2t. We determine the value of n from t the power of n here. So we have t the power of 1. So that's why our n is equal to 1. So now you have to determine your new ft. So our new ft is any function except t the power of n. So now you have t exponential negative 2t. So new ft is, we just close our t and our new ft is equal to exponent negative 2t. So therefore, new ft is equal to exponent negative 2t. So now proceed for the second step. Find Laplace transform for the new ft in order to obtain the fs. So therefore, fs is equal to, find the Laplace transform for the exponential negative 2t. Refer to the table of the Laplace transform. Exponent at is equal to 1 over s minus a. So from exponential negative 2t, our a is equal to negative 2. Therefore, 1 over s minus a, we substitute a become negative 2. So fs will become 1 over s minus 2. So 1 over s plus with 2. Okay, so this is the answer for the fs. So last step, apply the formula of the multiplying by Tn. Negative 1 the power of n. So you have to substitute to the formula. So we already determine our n is equal to 1 and we already get the fs is equal to 1 over s plus 2. N is equal to 1. Fs is equal to 1 over s plus with 2. So now you have to substitute the whole thing that you obtained before this into the formula of the multiplying by Tn. So therefore, negative 1 the power of n, so we substitute our n here become 1. Negative 1 to the power of 1. dn, n equal to 1. d1 over ds1 in this bracket fs, so substitute 1 over s plus 2. 1 over s plus with 2. So now you have to differentiate. Why you have to differentiate? Because you have d over ds here. So how to differentiate something that you have u divide with v? Differentiate by using quotient rule. vu prime minus uv prime divide with the v square. So the upper side is your u, the bottom is the v. U is equal to 1, so u prime is equal to 0. V is equal to s plus 2, v prime is equal to, okay, so we want to differentiate s plus 2. S is the variable, so differentiate s will become 1. Differentiate constant 2 will become 0. So now apply the formula of the quotient rule and substitute back into the position that you want to differentiate before this. Negative 1 the power of 1. So d over ds means that you have to differentiate only one time because you have power 1 here. Okay, so if you have power 2 here, means that you have to differentiate 2 times. So now when we apply for the first quotient rule, so there is no more sign of the d over ds. So we just write the answer for the quotient rule. V multiply with the u prime will become 0 minus u multiply with the v prime, 1 multiply 1 will become 1, divide with v the power of 2, which is s plus 2 the power of 2, s plus 2 the power of 2. So now you have to simplify. Negative 1 the power of 1 multiply inside will become negative 1 multiply negative 1. So this one will become 1 over positive 1 over s plus 2 the power of 2. Okay, so this is the answer that we obtain whereby we solve by using multiplying by Tn. So if you notice here, you have the same answer that you solve by using first shift. So that means there is no problem you want to solve by using which properties. If the question mentioned by using multiplying by Tn, then you have to follow the question. Otherwise, if not mentioned in the question, then it depends whether you want to solve by using multiplying by Tn or by using first shift. Okay, for next example, t multiply with the sine 3t. So you have t multiply with any other function. So this one we cannot solve by using first shift because we have t multiply with sine. So this one you have to solve by using multiplying by Tn. So this is the step if we want to solve by using multiplying by Tn. So the first step, you have to determine the n from t the power of n, and then you have to determine your new ft, which is any other function except the t the power of n. So from this function t multiply with the sine 3t, we have here t the power of 1. So t the power of 1, our n is equal to 1. So sine 3t here is our new ft, because new ft is the any other function except the t. So we close the t. So this is our new ft. So now step number 2, find Laplace transform for the new ft. So therefore fs is equal to, find the Laplace transform for the sine 3t. So refer to the table of the Laplace transform. So from the table of the Laplace transform, sine at is equal to a over s square plus a square. So we have sine 3t here. So our a is equal to 3. So now substitute into the formula in the table of the Laplace transform. A over s square plus a square. So we substitute our a to become 3. So 3 over s square plus 3 square. So simplify the denominator, 3 over s square plus with 9. So last step, apply the formula of the multiplying by Tn. So you have to substitute your n and your fs. So our n is equal to 1. So now apply the formula, negative 1 to the power of 1, d1 over ds1. So in this bracket, we substitute our fs. So our fs is 3 over s square plus 9. 3 over s square plus with 9. So the same thing, when we want to differentiate something divide, you have to apply the quotient rule. So u is equal to 3, v is equal to s square plus with 9. So differentiate u, differentiate 3 will become 0. So u prime is equal to 0. V is equal to s square plus 9. So is equal to, differentiate s square will become 2s. Differentiate 9 will become 0. So now apply the formula for the quotient rule. Negative 1 the power of 1. So we just copy back negative 1 the power of 1. So you have here d1 over ds1. So means that you only have to differentiate one time. So write the answer for the quotient rule in this bracket. Vu prime s square plus 9 multiply with 0 will become 0 minus with, because the formula for the quotient rule is minus, uv prime 3 multiply with the 2s. So will become minus 6s. Divide with v square, s square plus with 9. S square plus with 9, the whole thing square, because the formula divide with v square. So now you have to simplify. Negative 1 the power of 1 multiply inside with the negative 6s. So negative negative will become positive. So the answer will become 6 over s square plus 9 the power of 2. So this is the answer for the example B. Okay, for the last example, you have t square multiply with the hyperbolic cos of t. So cos h is the hyperbolic cos. So you have t the power of 2 multiply with the cos h, means that this one you have to solve by using multiplying by tn. So refer back to the step of the multiplying by tn. So you have to determine your n and your new ft. So from t the power of 2, our n is equal to 2. Our new ft is any other function except the t the power of n. So we close t the power of 2. So cos h is our new ft. Proceed for the second step. So fs is equal to, refer to the table of the Laplace transform. What is the answer for the cos ht? Okay, from the table of the Laplace transform, hyperbolic cos at is equal to s over s square minus a square. So now you have minus sign here. So there is a difference between hyperbolic cos and cos. So for the hyperbolic cos, you have s square minus a square. So for the cos, you have s square plus with a square. So now from cos ht, our a is equal to 1. So substitute to the formula for the cos hyperbolic here, s over s square minus a square. So fs will become s over s square minus 1 square. So simplify s over s square minus with 1. So this is the answer for the fs. So for the last step, apply the formula for the multiplying by tn. Substitute our n equal to 2 and substitute our fs equal to s over s square minus with 1. Negative 1 the power of n, our n is equal to 2. dn d2 over ds2 fs. Fs is equal to s over s square minus 1. So before this, example 1 and example 2, our n is equal to 1. So we only have to differentiate one time. But now you have d2 over ds2, means that you have to differentiate 2 times. So for the first quotient rule, our u is equal to s and v is equal to s square minus 1. So u is equal to s, u prime is equal to 1. Differentiate s will become 1. V is equal to s square minus 1. So therefore, v prime is equal to, differentiate s square minus 1. Differentiate s square will become 2s. Differentiate negative 1 will become 0. So now apply the formula for the quotient rule. So substitute back to the formula for the multiplying by tn. So therefore, negative 1 the power of 2. you have d square ds square. When we apply for the first quotient rule, the power here will be reduced. So this one will become d over ds. Okay, so first quotient rule we apply here. Substitute what is our answer for the quotient rule here. V multiply with the u prime, s square minus 1 multiply 1, s square minus 1 multiply with 1 minus with uv prime, s multiply with v prime, s multiply with the 2s will become minus 2s square. Divide with v square, s square minus 1 the power of 2, s square minus 1 the power of 2. So now you have to simplify. Negative 1 the power of 2 will become 1. D over ds, because we have one more times for the quotient rule. S square minus 1 multiply with 1 will become s square. Negative 1 multiply 1 will become negative 1 minus 2 s square. Divide with s square minus 1 the power of 2. Okay, so usually we don't expand the denominator here. Okay, you just have to simplify the upper side. So you have s square minus 2s square. So 1 minus 2 will become negative 1. D over ds, negative s square minus 1 over s square minus 1 the power of 2. Okay, so 1 at the front here is depend whether you want to write it or you don't want to write it. Okay, so now you have to differentiate one more time. So for the second quotient rule, our u is equal to negative s square minus 1. U prime is equal to, differentiate negative s square will become negative 2s. Differentiate negative 1 will become 0. V is equal to s square minus 1 the power of 2. S square minus 1 the power of 2. V prime is equal to, so you have s square minus 1 the power of 2. So you have two techniques how to differentiate this one. Is either you want to expand or you just direct differentiate. Okay, so I will show you how to direct differentiation. Bring power to the front. So you will have 2. In this bracket, we just copy down whatever you have here. So s square minus 1, s square minus 1, power will become 1. Multiply with differentiate terms in the bracket will become 2s. So now simplify. 2 multiply with the 2s will become 4s. 4s, s square minus with 1. So now apply the formula for the quotient rule. Therefore, vu prime, s square minus 1 the power of 2 multiply with the negative 2s. S square minus 1 the power of 2 multiply negative 2s minus with uv prime. So negative s square minus 1 multiply with the 4s s square minus 1. So make it in bracket, negative s square minus 1 multiply 4s s square minus 1. Divide the whole thing with the v square, which is s square minus 1 the power of 2. Take it another square will become s square minus 1 the power of 4. So now we have to simplify the whole thing here. Okay, so there are two methods on how to simplify. So I will show you the first method. Okay, so for the first technique, we can simplify by factorize the same term. Okay, so if you can see here, you have the term s square minus 1, s square minus 1 here, and also s square minus 1 at the denominator. But then all of these things, the power is not the same. Okay, so for this one power 4, this one power 2, and this one is power 1. So now how to factorize if there are not the same power? Okay, so you have to factorize the same term with the lowest power. Okay, so you have power 2, power 1, and power 4. So the lowest power is power 1 here. Okay, so we will factorize s square minus 1 to the outside. S square minus 1 to the outside, and then in this bracket, we will write back what is the terms. When you multiply with the s square minus 1, you will get back the whole thing at the upper side. Okay, so you already have s square minus 1 here. What is the terms that you have to multiply inside so that you have s square minus 1 the power of 2 multiply negative 2s. So we should have another s square minus 1 the power of 1 and negative 2s. So that when we multiply back s square minus 1 multiply back with s square minus 1 multiply negative 2s, you will have the same term as your original here. Okay, so now for the last one here, you have negative s square minus 1 multiply 4s multiply s square minus 1. We already write the s square minus 1 at the front. So now what is the terms that you have to write at the behind here? So you still have to write negative s square minus 1 multiply with the 4s. Negative s square minus 1 multiply 4s. So when you multiply back the whole thing, you will have back your original terms here. Divide with s square minus 1 the power of 4. Okay, so now you have s square minus 1 with the power of 1 outside, and you have s square minus 1 with the power of 4 at the denominator. So we can cancel out. But for the denominator here, this one will become power 3. Equal s square minus 1 multiply negative 2s minus negative s square minus 1 multiply 4s. Divide the whole thing with s square minus 1 the power of 3. Okay, so from here we can simplify more. Expand the upper side. S square multiply with the negative 2s, negative 2s the power of 3. Negative 1 multiply negative s plus 2s. Negative s square, and then multiply with the 4s. This one will become positive 4s the power of 3. Negative multiply negative 1 multiply with the 4s. So will become positive 4s. Divide the whole thing with s square minus 1 the power of 3. So if you have the same term, you can cancel out. Negative 2s the power of 3. This one you have positive 4s the power of 3. So negative 2 plus with 4 will become positive 2. 2s the power of 3. Positive 2s plus positive 4s will become positive 6s. Divide the whole thing with denominator s square minus 1 the power of 3. Okay, so this is the final answer when we simplify by using the first technique, by factorize the same term that you have at the upper side and the denominator. So for first method of simplify, we simplify by factorizing the same term with the lowest power. So now for the second method, So this one we will simplify by expand all the terms at the upper side. Okay, so expand means that you will expand everything that you have at the upper side here. So now we have to expand s square minus 1 with the power of 2. S square minus 1 the power of 2 will become s square minus 1, s square minus 1. So it will become 2 bracket now. Multiply with the negative 2s. So this one, you have to multiply with the 4s first. Negative s square multiply with the 4s will become negative 4s the power of 3. Negative 4s the power of 3. Negative 1 multiply 4s will become negative 4s. Multiply with s square minus 1. Divide the whole thing with s square minus 1 the power of 4. So simplify first two terms here, s square minus 1, s square minus 1. S square multiply s square, s the power of 4. S square multiply negative 1, negative s square. Negative 1 multiply s square, negative s square. Negative 1 multiply negative 1, positive 1. So make it in bracket, and then you have to multiply again with the negative 2s. So terms at the behind here, you have to expand. Negative 4s the power of 3 multiply with the s square minus negative 4s the power of 5. Negative 4s cubed multiply with the negative 1, positive 4s cubed. Negative 4s multiply s square, negative 4s the power of 3. Negative 4s multiply negative 1, positive 4s. Divide the whole thing with s square minus 1 the power of 4. So now simplify s the power of 4 multiply negative 2s. So negative s the power of 5. Negative s square multiply negative 2s, positive 2s cubed. Negative s square minus 2s, positive 2s cubed. One multiply negative 2s, negative 2s. Negative multiply inside positive 4s5. Negative multiply with the positive 4s cubed, negative 4s cubed. Negative multiply with the negative 4s cubed, positive 4s cubed. Negative multiply with the positive 4s will become negative 4s. Divide the whole thing with s square minus 1 the power of 4. So if you have any term with the same power, so you have to simplify. So negative 2s the power of 5, positive 4s the power of 5. So negative 2 plus 4 will become 2s the power of 5. Positive 2s cubed, positive 2s cubed. Negative 4s cubed, positive 4s cubed. Okay, so negative 4s cubed can be cancelled out. Positive 2s cubed plus positive 2s cubed will become positive 4s the power of 3. Negative 2s minus 4s, negative 6s over s square minus 1 the power of 4. So this is the final answer, whereby we simplify by using the second method. So if you can see, there are not the same thing, but then if you simplify more, then it will become the same thing. Okay.